We want to look at here is something called dispersion. It's again something we saw in year 11, but we do need to know a little bit about it. It goes back to Newton's theories on light, and what he did was he found that when he put light white into a prism, it split up into different colours. Doesn't look like it at the moment, but you should know from your junior science that white light has 3 primary colours that can make every other colour, and those are green, blue and red. So when you put white light in, you've got these 3 colours, but they've all got different wavelengths. 400 nanometers is blue, 500 nanometers is green, and 600 nanometers is red. The longer wavelengths are the ones that have the lower frequencies, and lower frequencies mean lower energy. So red's got the lowest energy, blue's got the highest energy and shortest wavelength. They all have the same speed, c, 3 times 10 to the 8 meters per second. And what happens is that the different wavelengths have a different refractive index. Remember, we talked about refractive index. So for a piece of plastic, it might be 1.5. That means the light slows down and the wavelength gets smaller, and if it hits at an angle like this with our normal in there, then we're going to get a bending towards normal, and when it gets back over here, it's going to bend away from the normal. Now the top one I've shown there is red. It has a refractive index that is smaller than blue, so when blue comes through, it gets bent more. So this whole phenomenon, so you could imagine that green's probably in the middle there somewhere. The refractive index seems dependent on the wavelength. So we have the splitting up of the white light into different amounts, or the amount of bending is different dependent on its wavelength. So this is called dispersion. In year 11 you're expected to be able to draw a diagram like that. And you need to remember the order. The red gets bent least and the blue the most.